Boiling point elevation. That's what happens when you dissolve more solute in a solution, is the boiling point gets higher. That means that if you put salt in water, that salt water now boils at over 100 degrees in normal atmospheric pressure. But I really want to talk about why this happens. And it's important to remember what boiling is, which is when the vapor pressure of the liquid matches the external pressure. Now, where does that vapor pressure come from? Well, it's from water molecules on the surface evaporating, basically jumping into the vapor phase, becoming gaseous. By the way, all these little dots and bigger dots all are supposed to represent water molecules. So all the ones from the surface can jump into, kind of jump into the air here, fly off of the surface, and that establishes some amount of gas in the chamber, which provides a pressure, and that is your vapor pressure. And at 99 degrees Celsius, this vapor pressure very nearly equals the external atmospheric pressure. And for pure water, one more degree higher, you're going to get the vapor pressure matching atmospheric pressure, and you're going to get boiling happening. Now let's look at what happens when a solute is dissolved. I'm going to make these very large solute molecules. Some of them end up at the surface of the solution, and they block out some of these water molecules from the surface. So there's less waters on the surface that are able to jump from the liquid to the gas phase. So if I had like 5 upwards arrows over here, I'd maybe only have 4 in this situation with solute. And that makes the vapor pressure go down. So at that same 99 degrees Celsius, we now have a slightly lower vapor pressure, which means we're farther away from matching atmospheric pressure and boiling. So we have to raise the temperature above 100 degrees, maybe 102, in order to get our fifth arrow, by which I mean the extra needed vapor pressure to match atmospheric pressure, and therefore boil the solution. And the amount of solute definitely does matter, because the more solute, the more you're going to block the waters from the surface. And it's the overall number of particles, solute particles, that matters. So if you had magnesium chloride, that would break into 3 different ions, right? So you'd have 3 times more particles than it looks like. If you were to just say there's 2 molar magnesium chloride, you'd actually have 3 times that too. You'd have a 6 molar total concentration, or a 6 osmolarity. So to equal the effect of your 2 molar magnesium chloride, you'd have to have about 6 molar of a non-ionic compound. So for instance, like glucose or something like that. So the change in boiling point or freezing point of the 6 molar glucose would be the same as the 2 molar magnesium chloride. Although it's not quite this simple, because I'm assuming full dissociation of the magnesium and chloride atoms. But later we'll look at the Van Hoff factor, which accounts for non-complete ionization.